Today's lesson on Cappecci's Corner, we are going to graph system of equations, and you can see how excited I am because we are starting a new chapter. Before we start graphing, we have to know what a system of equation is. And what that is it's two or more equations that have the same variables, meaning they both have x's and y's, or they both have a's and b's. And what is a solution? When we ask you to solve it, what actually are we asking you to do? And what it is if you were to graph these two lines, it's the point or points that both equations have in common, meaning where do they intersect. We have three different types of solutions. Our first one is just one solution, meaning they intersect just at one spot. The second type is no solution, meaning they never intersect. If you look at these parallel lines, they have the same slope, so they will never intersect. So parallel lines have no solution. And the last type is infinite solutions. If we were to graph one line, in this instance the blue line, and if I were to graph another line right on top of it, they would have an infinite number of solutions, meaning there are many solutions that would work in both equations. In the end, what we're asking when we want to know that how many solutions there are, it's the number of times that the line touches. So, touches one time, doesn't touch at all. And in this third example, in the infinite solution, it touches an infinite number of times. So again, the bottom line is the point of intersection is the solution of the linear system. Our first question is the ordered pair a solution to the system of linear equations? And so we have our point 4, -1, and then we have two equations. Now remember, these two equations are two lines. So basically what I'm asking is this point found on each of these lines. If it is found on each of these lines, then it is the point of intersection, therefore it's the solution. So what I need to do is I need to substitute these values in. Now remember, this is my x and this is my y, to see if I get a true statement. So in the first equation I have 3 times 4 minus 1 is equal to 11. So this gives me 12 minus 1 is equal to 11, so that's true. So what that means is the point 4, -1 is on that line. Let's try the second equation. So I have 4 minus 2 times -1 is equal to 6. This gives me 4 plus 2 is equal to 6, so that is true. So because this point is a solution to both of these equations, then the answer is yes. This is the solution to the system of this given linear equations. And there are a few different ways we can solve a system of equations, and in today's lesson we're going to do that by graphing. So my first equation is x is equal to 3. Now that's a vux, meaning it's a vertical line. That's what that V stands for. So everywhere we have an x value, it is 3. So this is my vertical line at x is equal to 3. My second equation is y is equal to -2. That's a hoi, meaning it's a horizontal line because we have a y equals. So all the y values on my given line are going to have a value of -2. So here's my equation there. Now, if I check and I find out where my point of intersection is, it's right here. That's where the two lines meet. So that has a value of 3, -2. That's my point of intersection. Now, I want to substitute it in to check my answers. So my x value is 3 and my y value is -2. When I substitute these in to check, I can see I'm going to get a true statement. So I have x is equal to 3. So if I substitute 3 in, which is what I have in my solution right here, that's true. And then I have y is equal to -2. Again, I'm going to do the same thing. I'll substitute -2 in for y, and I also have a true statement. So I know that I have selected the correct point of intersection. And remember, the point of intersection is the solution to the system of equations. Now in our next set of equations, I have y is equal to -x minus 2 and y is equal to 2/3 x plus 3. In my first equation, I have my y-intercept is equal to -2, so that's where I'll start graphing, and my slope is -1 over 1. So I'll go down 1 to the right 1. So my y-intercept is -2. I'll go down 1 and then to the right 1, and I'll do this several times. I'll also go in the other direction because when you're graphing, to find where lines intersect, you need lots of points and you want to be as accurate as possible. So here's my graph of my first line. And now I'll go on to my second line there. So I have y is equal to 2/3 x plus 3. In this case, my y-intercept is 3. My slope is equal to 2/3. So that means I'm going to go up 2 and then to the right 3 from my y-intercept. Start at my y-intercept, which is 3. I'll go up 2 and then to the right 3. So I know I'm here, but that is going further from the line. So I know I need to go also in the other direction. So I go down 2 and then to the left 3, and there's my point of intersection right there. I can graph one more point if I want. Down 2, and then my right over 3, I'd be over here somewhere. I'm going to graph my line. And I have found that my point of intersection is right here. Right? So that coordinate is -3. That's my x value, 1. So that's my solution to my system of equations. So I'm going to check it into my original equations. I can say for sure whether I did everything right. Did I graph it right? So here are my two equations, and I'll substitute it in. So remember, this is x and this is y. So I have 1 is equal to negative, and I have a minus -3 minus 2. So I have 1 is equal to +3 minus 2. That's true. Now let's check it in my other equation. So I have 1 is equal to 2/3 times -3 plus 3. Because 1 is equal to, now this becomes -2 plus 3, so I know that's true. So again, -3, 1 is my solution to the system of equations, and because that is the point of intersection, that's where the lines meet. Looking at my next set of equations, I have y is equal to 5x plus 4. So I know that my y-intercept is going to equal +4, and my slope is equal to 5/1. So I'm going to go up 5 to the right 1. So I start at +4 for my y-intercept. Now this is a small graph, so I don't have enough room to go up 5 to the right 1. So I'm going to go down 5 to the left 1. It's the same idea, it's still a positive slope. So I go 1, 2, 3, 4, 5 to the left 1. Now I'm going to graph my line, put my arrows on the end, and I'm ready to graph my next line. So I have my y-intercept is equal to -2, and my slope is equal to 5/1. So again, I'm going up 5 to the right 1. So I start at -2, and I go up 5, 1, 2, 3, 4, 5 to the right 1. Graph my line. Arrows on the end. Now, in looking at this, these lines do not touch, and the reason they don't touch is they're parallel lines. Remember, parallel lines have the same slope and different y-intercepts. So what does that mean in systems of equations? Well, we're looking for a solution, and the solution, remember, is where the lines touch or intersect, and parallel lines will never touch. So in this case, this system of equation has no solution. In looking at our last example for today, our equations of our lines are not in slope-intercept form, so I need to do that first before I can graph. So my first equation is 8x minus 4y is equal to -12, so I need to get y by itself. So I'll subtract 8x to both sides. I have -4y is equal to -8x minus 12. Divide both sides by -4. Remember, I have to do that to all terms. And I have y is equal to 2x plus 3. So that's the equation that I'll graph first. Again, my y-intercept is 3. My slope is 2, meaning I'll go up 2. So I'm going up 2 to the right 1. I'll also go down 2 to left 1, and I'll do a couple more points. Down 2 to left 1, down 2 to left 1, down 2 to left 1, so I can get a nice line. So here's my equation of that line right there. Y is equal to 2x plus 3. Now, in my other equation, I'll do the same thing. I have to divide everything by -1, so I have that y by itself. So I have y is equal to 2x plus 3. Now, if you notice already, my equations are the same. They're exactly the same, meaning they're going to be the same line. So if I would do the same thing with my green line, going up 2 to the right 1, starting at my y-intercept of 3, this line is going to go right on top of that line. So what does that mean? When we're asking to solve a system of equations, we want to know where they touch or intersect. In this case, they intersect in an infinite number of points all along that line. So the solution is that there are infinitely many solutions. Infinitely many solutions because these lines don't touch in one spot, they touch in an infinite number of spots on those lines.